Hello, Internet. Okay, now I am back and connected. Let's see if Discord actually keeps up. I was getting these cycles of being disconnected and then reconnected and disconnected and reconnected. But maybe it works now. If it still breaks, I think I'm gonna record this video offline. But let's see. Let's see how Discord fares. So, day 13 of Advent of Code. Point of incidence. With your help, the Hot Springs team locates an appropriate spring which launches you neatly and precisely up to the edge of Lava Island. There's just one problem, you don't see any lava. You do see a lot of ash and igneous rock. There are even what look like grey mountains scattered around. After a while, you make your way to a nearby cluster of mountains, only to discover that the valley between them is completely full of large mirrors. Most of the mirrors seem to be aligned in a consistent way. Perhaps you should head in that direction. As you move through the Valley of Mirrors, you find that several of them have fallen from the large metal frames keeping them in place. The mirrors are extremely flat and shiny, and many of the fallen mirrors have lodged into the ash at strange angles. Because the terrain is all one color, it's hard to tell where it's safe to walk or where you're about to run into a mirror. Or is this gonna be a pathfinding problem? You note down the patterns of ash, period, and rocks, hash, that you see as you walk your puzzle input. Perhaps by carefully analyzing these patterns, you can figure out where the mirrors are. For example, okay, so there's two maps. Two maps. To find the reflection in each pattern, you need to find a perfect reflection across either a horizontal line between two rows or across a vertical line between two columns. In the first pattern, the reflection is across a vertical line between two columns. Arrows on each of the two columns point at the line between the columns. So what is this? Okay, so arrows on each of the two columns point at the line between the columns. So it's like this kind of line. In this pattern, the line of reflection is the vertical line between columns 5 and 6. Because the vertical line is not perfectly in the middle of the pattern, part of the pattern, column 1, has nowhere to reflect onto and can be ignored. Every other column has a reflected column within the pattern must match exactly. Column 2 matches... Oh, column 2 matches column 9. Column 2 matches column 9, column 3 matches 8. Okay, so yeah, so that's how this mirrors. Column 3 matches 7 and 5 matches 6. Yeah. Oh, I see. Okay, so this... Yeah, so this image mirrors vertically. Or like horizontally across this vertical line. Yeah. The second pattern... Wait. So yeah, there's two patterns. The second pattern reflects across a horizontal line instead. Okay, so this is the line of reflection here. So this one reflects like this. This pattern reflects across the horizontal line between rows 4 and 5. Row 1, yeah. Row 1 would reflect with the hypothetical row 8. But since that's not in the pattern, row 1 doesn't need to match. Yeah. The remaining rows match, yeah. To summarize your pattern node, add up the number of columns to the left of each vertical line of reflection. To that also add 100 multiplied by the number of rows above each horizontal line of reflection. Okay, so that's just to create the hash of the like a checksum of the answer. Find the line of reflection in each of the patterns in your nodes. What number do you get after summarizing all of your nodes? Okay. I see, okay. Well, yeah, I mean, naive algorithm, check every possible split. So if the width here is W, then I check W possible starting locations, and then for each of them I walk all these columns. So that's W squared. But I don't want to check all of these. Yeah, so what I'm gonna do is I'm gonna collapse, if that's possible. I mean, at least this small puzzle input is possible. So what I can do is I can collapse, like I can compute like a binary number, for example, like this is like 1s, 2s, 4s, 8, 16, 32, 64. So I can create a binary number from this pattern and have one-dimensional array of all of these elements. So then I would be going through all of these elements, thinking like what's the possible mirror location, then check back. With each. Yeah, so that's a squared, and here this is the same problem, just run it the other direction. But this is squared. Is there a better way? Can I accumulate this? Can I accumulate these numbers somehow? Well, okay. No. Like, this is not gonna be squared, actually. This is gonna be practically linear. No, this is gonna be linear. Because I'm gonna test each possible placement, and then I start walking. But immediately when I find a column pair that doesn't match, then it aborts. And you cannot have a quadratic number of matches. Well, I guess pedantically, theoretically, you could craft such an input, but that would I like that's not gonna happen in here. So yeah, so practically this should take practically linear time. Okay, okay, let's do that. Cool. So get back to the system, but before I do this, actually, now today I want to take this disk, and so I have cut the notches here to this disk. So I'll flip this around and let me see what I have here for this old disk, because this other side is getting full. So what do I have here? I think I have the remains here of a old demo. Yeah, I was watching some demo. So now the question is, what was the I forget. I formatted this disk on the other side on maybe day something. N new. Okay, so just to be sure, let me get that out. I don't accidentally format that one. -n column name ID AOC 02. Okay. 664 blocks free. Cool, that's great. Okay. And load C++64 from disk 8. And then run. Cool. Okay. And now let's go to the Advent of Code client. And get saving the puzzle inputs. So these were the two examples. Oh, do I save this? Maybe I'll save this in one file. Save to device line 2023.example13.txt. Okay, and then check the puzzle input. Save to device 9 2023.input13.txt. And this is gonna be maybe some really huge map again. Cool. All right. Okay, so first I want to know what the dimensions are. And today I am reading with Caroline. Let's go 200. While f gets line size of line from file. Int max width 0, max height 0. Max width equals max of max width in string length of line and plus max height. Oh, but if okay. Say cool. Okay, so what are the maximum extents? Maximum width 10, maximum height 7. How about the actual input? What's the maximum size of the input? Oh, not large at all. 18 and 11. 18 and 11. So okay. Let me write that down so I remember. 18 times 11. 18 times 11. So that means that I'm building two one-dimensional arrays of numbers. U24 width. Yeah, and then height. Or let's do X and Y. And here let's do width equals 0 and height equals 0. And if length is more than 1, height equals 0, continue. Okay. Otherwise plus height. So I get this stuff. So I guess I'm walking. Yeah, I'm gonna be walking the. Wait, I equals 0, I is smaller than length. Actually, if L len minus 1 smaller equal 32 minus length. I think this is always true. So with f gets you get that new line at the end. So I need to strip that away. But I'll just keep this here, this check, because it doesn't hurt me, but I think, yeah, eventually I do wanna, well, okay, whatever. So oh, and again, this needs to go here. plus I. So now I'm creating these one-dimensional images. In the x direction. In the x direction, xi equals xi shifted left by 1 place, and then ordered by line I equaling the hash symbol. And then the in the y direction, so I need a y in the y direction I need a temp value. Val equals val shifted left 1 place ordered by L I equaling the hash. And actually, let me just put this. I can. No, I can put this in here. Why? Okay. Yeah. Does this make any sense? This width I'm not using. And here, mem set x0 size of x. And same for y. Yeah, looks pretty good. Okay, let's do a solve function. Int solve. Actually, are these... Do these things match? So here I would be solving... I would have the sum and sum plus equals solve with height, but go not there. Yeah. Yeah, they do match. Okay, let's save. Function definition is not allowed. Okay, now I got something really desynced. Cool, okay, and okay, so what happens with this? I get a bunch of numbers. Oh, and now I'm running on the actual input. No, this is gonna take ages. Okay, let's see what happens if I break this. Oh, we got lucky, okay. So example input. Oh, I only solved the first one, so I need to do sum plus equals solve with height here still. Okay. So here I can see the mirroring, right? There's these two, along the first line, there's these 237, 66, 103, 24. So that's the mirroring. Perfect, okay. And then on the fourth line, second line, there's 38590. No, wait. Then there's again 358 and 2. Okay, so something is odd with the second line. Third line. Ooh, also doesn't quite match up. Fourth line is correct. So first and fourth lines are correct, but what is going on with the second and third lines? Yeah, so that's not quite correct. So what am I printing on the second? I'm printing the Y values. So these ones. Oh, no. No, wait. For the... Now I'm starting to feel confused. So the X values project vertically. Everything gets shifted left by 1. From so far, and then the new one is fed in. And then for the second one, collapsing horizontally. No, this does feel pretty good. YH equals... Yeah. Let's double check what this looks like against our inputs. So I would have, for this one, I would have how do I even get to such big numbers, because I have 7 rows. Actually, that's odd, because I only have 7. No. Actually, no. That's all correct. 7 rows. So maximum of 128 on the first line. Yeah. Yeah. No. The second column. So that's 20. No. First line number, second number 24 is 8 plus 16. So that's this one and this one. So that's 24. And this is 1, 2, 4, 8, 16, 32, 64. So 64, 70, 80, 88, 89. Yeah, very first value is 89. So these are correct. But what is happening then? So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbers horizontally. So I have 1, 2, 4, 8, 6, 32, 64. And 64, 122, 56. So that's 7 plus 96 plus 256, which is 352 plus 7. Oh, 352 plus 7, which is 359. Oh, I don't have a 1. No 1. 358. Yeah, that's exactly the correct. The first value is 358. Then 90. 2, 4, 8, 16, 32, 64. So that's 96 plus 10. That is not correct. Why do I get the second value incorrect here? This should be 2, 8, 16, 32, 64. No, not 90. 70, 80. Jeez. Yeah, that's 90, just as it should be. Then we get 385, which is 1 plus 128 plus 256. Yep, that's correct. Then we get 90 again, and 102. Oh, I'm so dumb. I'm so dumb. This was all correct. Oh, now I've been debugging because they so slow. Okay, so of course not both lines need to, both dimensions need to find a mirroring. It was just one direction. So so of course first and fourth lines find the mirroring. Debugging when there's no bug. Okay, so I wrote everything correct. And I was just super dumb to not figure that out. Well, I mean, good. It's pretty good to have it that way, right? So here, bool is mirror position. And I'll do U34 array, and then U8 len, and then U8 index. So this function returns true if this position is a mirror position. So for I greater than 0 and no, U8 J is 0. I minus j greater than 0 and I plus 1 plus j smaller than length. Yeah, I think this should work. Plus plus j. If array I minus j is not equal to array I plus 1 plus j, become false. Become true. So now I'm testing if yeah, if the given position can start or starts mirroring. And the leftmost thing can never be a mirror. And the rightmost thing can also never be a mirror, because then there's no No, actually the leftmost position can be a mirror in my convention. So when j is equal to 0, this is array I and array I plus 1. Yeah, so that's kind of a silly mirror, but yeah, but this one can never be the case, so I don't need to check for this. If it's mirror at x of width w and at position I. What was the scoring mechanism? The scoring mechanism was add up the number of columns to the left of each vertical line of reflection. So x's are projected vertically. so this would be I. And then if is mirror y height I equal 100 multiplied by I. Okay, let's see what happens. Nothing, because we don't print the result. Result. Okay. So now I should be getting 405. $304, because this is one, yeah, I plus 1 plus 1. Oh, and then I'm gonna crash. Okay, that's interesting. That was a crash, so device 9, 23, 13A. So this needs to be I plus 1 and here I plus 1. Okay, 405. Let's go to the input and hope for the best. This might take a little while. The disk drive is not that fast. Oh, and then of course it immediately finished when I asked 27664. Well, that looks like a nice number. Let's go to the client. Answer 27664. Yes, yoo-hoo! That wasn't too hard. 47 minutes. I think that's my record so far for the first puzzle solve. Okay. So maybe the second one is gonna be something really, really hard. We'll see. And oops. Yeah, let's print this out. Go here. Okay, here we go. That's the puzzle. Cool, okay. You reach them walking through the Valley of Mirrors and smack. Run directly into one. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, you discover that every mirror has exactly one smudge. Exactly one period or hash should be the opposite type. In each pattern, you will need to locate and fix the smudge that causes a different reflection line to be valid. The older reflection line won't necessarily continue being valid after the smudge is fixed. Here's the above example again. The first pattern smudge is in the top left corner. The top left hash were, if the top left hash were instead a period, it would have the different horizontal line of reflection. So in the first part, the first part was this. So it was between 5th and 6th. If the top line hash were instead a period, it would have a different horizontal line of reflection. So the reflection is going to be from horizontal to vertical. With the smudge in the top left corner repaired, new horizontal line, yeah. In the second pattern, the smudge can be fixed by changing the 5th symbol on row 2 from period to a hash. Now the pattern has different horizontal line reflection between rows 1 and 2. Ooh, okay. So we get 400 with these two. Fix the smudge and find different line reflection. So this means that 1 bit, so there's a smudge, 1 period of hash should be of the opposite type. So in my representation, that means that 1 bit has to change. Oh, but is that easy? Is that gonna be easy? So here I'm checking whether the values are the same. But instead, let's check the bit difference. The bit difference. Is this gonna work? Here's the bit difference. And if XOR used plus bool is power of 2 U34x. Return x and x minus 1. Yeah. Bool need XOR. Oh, actually, no. Need XOR equals x and yeah, need XOR. XOR equals need x XOR. Yeah, the naming is not the best, but expected. Let me save this on to ECTP. And then I have my early out is equal XOR used. Oh, but no, this needs to be U8. If X return 0. If this return 1, return 2. XOR used equals 0. And then U8 XOR need XOR of this thing. And then why am I getting an error on this line? I'm not quite sure. If XOR plus XOR used is greater than or equal to 2, greater than 1, then I've blown it. Return XOR XOR plus equals oh, I think I cannot name a variable XOR. Is that the case? Yeah, because that's going to be the yeah, that results to an operator. So does that work? $105. I should be getting 400. I should be getting 400. No, return... Oh, return XO equals 1. 400. Yes, that is the right answer. 400. Woohoo! Okay, so let me save. Oh, this might just work. Got the right answer on the example input, just like that. Just like that. Okay, so take it to the right one and Linus equals 0. Let me just print some progress. It's going through pretty fast. How many inputs were there? Like 1,000 or something like that? Often there's exactly 1,000 inputs. Oh, there's more than 1,000 inputs. Oh, that's because I'm printing this on every line, not just... Oh, crap. Not just on every every input square. Okay, so this is a lot of printing. Which... way more than what I thought I would be doing. Oh, hi, Akariman. I think there was less than 200 maps. Okay, okay. 33911. 33991. Okay, yeah, that didn't fortunately take that long. Let's see if this will work. 33991. Yep! Wow! Wow, 1 hour and 1 minute of total time. Gee, this is probably the quickest solution that I've got so far. Both right on the first go and yeah, the only one I was debugging this issue that turned out not to be issue. I was just misunderstanding it. That's pretty cool. Oh, that's pretty cool. Then the C64 didn't have much trouble at all. 2 stars. GG, thank you. Yeah, no, C64 has all the 26 stars. Actually, I wanna run just for posterity. Oh gee, the printer paper, yep. I mean, this is how the elves are sending messages to me every morning. This is a super classy stream. Well, thank you so much for the kind words. Yeah, this is just like going just like doodling about on this old Commodore setup. Yeah, the kind of Christmas tomfoolery that you could think of. But I'm not curious to see how long it takes for the C64 to compute this. I think I got lucky on this puzzle by going for the binary representation immediately without like comparing the individual characters like one at a time or anything like that. Like I think a lot of people will go that they start testing these positions and they will compare at every test these individual characters, and that's gonna take a lot of time, and then they need to do that logic of where is the smudge and all of that. 1 minute 54 seconds. So the binary representation really saves because then you can do this actually I think a better number of smudges. Let's name it like this. Number of smudges. That's a good descriptive. N smudges, so we can fit it in 8 columns. Yeah. I did bit masking too. Yeah. It really helps because then you can calculate this in one operation. So that really makes it easier. Can I do? Yeah. Oh, absolutely love it. Dot matrix printer lasted at least 10 years. I mean, these are not scams like modern Canon and HP printers. It's just so ridiculous. Only reason to decommission was no ribbon cartridge to be found. The new computer had no parallel port. Actually, I bought for this thing. I bought a brand new ribbon cartridge. Like, these are still manufactured. That's the weird part. Like in November when I got this idea of like, let's go full on Commodore. I first thought about like doing like a printer thing. But then I thought like, well, yeah, nobody does these ink ribbon cartridges anymore, so so that's, you know, that's a lost cause. And then I found these YouTube videos where people are basically reviving their old ink ribbons by they put in like some WD-40, like anti-rust oil into these to basically like invigorate the ink. And then I was like, well, should I do that? You know, like that's gonna be messy and like a lot of hassle. But then I just found a website that sells brand new ink ribbon. So this is a brand new ink ribbon that I got from that website. I mean, I did have to pay, like it's a US website though, so I did have to pay customs, which was a little bit annoying, but it wasn't expensive at all, and the print quality is just really nice. So that made the whole thing, like otherwise I probably wouldn't have bothered at all with this thing. So yeah, revival like vinyl records ribbon cartridge. Yeah, for sure. Cool. Okay, today's puzzle was a fun one. The part 2, it was nice because at first it was like overwhelming feeling like, oh, do I need to do all sorts of tests? You know, start doing like some quadratic time combinatorial stuff or something like that. But yeah, none of that, and then it just got so simple. It got so simple in the end. So that's really nice. Okay, but yeah, it's my lunch break here. Oh, sorry, I didn't catch day 12 part 2. How was that for you? Quite a bit of compute there. So I finished it in 9 minutes and what was it? Like it took a little bit less than 10 minutes for the C64 to compute the result. I have a full write-up in my blog. So I'm writing this kind of journal every day that describes how it goes for the C64. So yeah, so I was able to solve the second part. The solution I had was like a basic standard recursive memoization. So I had a recursive function that basically recurs back to do, when you meet a question mark, do both choices. And then a memoization cache on front to cache the result. And then one optimization I did, originally my runtime was about 16 minutes on the C64. Then one optimization that I added, I put in a global look ahead cutoff heuristic, or not. It's I mean, you could say that it's a heuristic, but this kind of limit the idea being that if you skip too many question marks, then you might not have space anymore to fit the remaining broken strings. But the solver wouldn't know that
because it's still in the middle. It hasn't looked at the end of the input to understand that that there's no room left. So I did this kind of accumulation across the string of how many spring positions are left, and if there's not enough, then early out. So you can prune. So that removed about 33% of these recursive calls, and it took the runtime from about 16 minutes down to just under 10 minutes on the C64, and it was something about 2.5 milliseconds on the PC. So that kind of tells like what the size difference is for like if you're running 2.5 milliseconds on PC, that's like 10 minutes on the C64. It's kind of crazy. Like there's like 200,000 times of a speed difference between these things. Hi Rewoke. I feel like we're just bar hopping stream to stream. Yeah. Hope you had a good good to drink on this stream or good day. But in any case, this was everything that I had for today. So I need to actually run to have a work day. So this was like an extended lunch break that I had here, and now I need to go back to work. But yeah, pretty happy that today's solution was pretty short. So I was able to manage this on my lunch break and not have to go and resume it in the evening. But anyhow, hope you had fun with today's puzzle, and yeah, nice for everybody who popped up. And I will be back tomorrow with day 14 as usual. So take care, guys. I'll see you later. Bye.